Hello, everyone. This is Ms. S, and we are going to do some doodle notes about how the COVID vaccine is made and how it works. You are going to print a template page if you're lucky enough to have access to a printer that looks like this. Or you're just going to click on the link and make your page look like this, either on binder paper, white paper, graph paper, whatever you have is fine. So let's jump right in. I've got a little clip for you to watch to start us off.
This is how coronavirus invades your body, sinking its crown-like spikes into your cells, using molecular deception to pick their locks, and hijacking your body. But there is one way to prevent this, by using one of the virus's weapons on itself. Hey smart people, Joe here. Right now, there's about 7 billion people all waiting for the same thing, a vaccine that will protect us from the virus causing COVID-19. And if you're like me, you wanna know what's in it, what makes it work. Making a vaccine and getting it out to the public is a long process with a lot of steps, so we can make sure the vaccine is safe and effective. And it's pretty typical for that to take 10 years or more. Now, in an emergency, like this pandemic, well, we can't skip any of those steps, but we can speed this up by doing some of them at the same time. But none of that can happen until you figure out the first step. What do you put in your vaccine that will make it protect people? And that's what we're going to talk about.
And that's what we're going to talk about today. So, important to note, they did not skip any steps in making this vaccine. I know that's a big question that we get a lot.
This is how coronavirus invades your...
Skip that. They didn't skip any steps. So, it is still just as safe as any other vaccine. However, we're about to learn how they luckily have been doing research on this sort of thing for quite a while now. And they were able to develop a way to get this done quite quickly. So, first of all, we're about to learn some things about vaccines, and a big part of a vaccine is tricking your body into creating these things that we call antibodies. So, I want to make sure that you have a definition of what an antibody is. You can draw it as like a little figure here. They're actually a kind of Y-shaped, and the big thing we need to know about antibodies is that they are the things that attach to the invaders or the germs, maybe a virus, to tell some other good cells to destroy the invader. We call the invaders that they attach to antigens, so you can think of those as opposites. But the antibodies are the good guys that attach the invaders and kind of flag them and say, hey, other cells, white blood cells, get rid of this guy. He's an invader. We have another clip.
Let's step back for a minute. What does a vaccine do? Well, it trains your immune system to know what a germ, like a virus, looks like, so that it can recognize the germ, fight it off, and keep you safe.
There you go. On the next slide, it is going to ask you what exactly is
Let's
a
step back for a minute.
vaccine, and you are going to fill it in. So it trains your immune system to know what a germ, like a virus, looks like. Why do we care about this? Well, we're about to watch a clip that kind of gives us a why do we care?
When your body fights off a virus, it makes antibodies that act like soldiers. They learn what the enemy looks like so they can fight it again successfully in the future. Vaccines help us do that, training our immune soldiers to be ready in the war against COVID.
The goal of a vaccine is to induce the immune response that's a consequence of natural infection without making people pay the price of natural.
So watch that as many times as you need. Make sure that you go back and fill in why do we care? What does that vaccine do for us anyway? we're moving on to the next section. We are going to draw a simplified model of the coronavirus. You've done a version of this before. He is going to talk about something called an M protein, an E protein. The S protein is what we care the most about. And then inside, he doesn't talk about this part, but inside is the RNA. Now, you'll be learning about DNA more in depth in 8th grade, but what I do want you to know is RNA is half of a strand of DNA, and it is inside most every one of your cells, and it is also inside coronavirus. I'm going to actually put this on
This is the virus that causes
slow speed because he goes pretty fast on this one. And watching it slowly is a little bit helpful here. Okay, and we're ready.
that causes COVID-19. The outer shell is made of a few different kinds of proteins, but these
Okay, these are the ones that you want to write down. So the M, or the yellow, is the membrane protein. The E, the red stuff there, is the envelope protein. And the S is the spike protein. That's the most important one. He is about to go a little more into depth about what we need to know about the spike protein.
These proteins sticking off the side are the most important part, the spike. These spikes are what give this family of viruses their name, the coronaviruses, because they look kind of like a crown. The coronavirus uses that spike to sneak into our cells. The three-dimensional shape of that spike is super important because that exact shape is what lets the virus latch on to receptors on the outside of our cells, almost like picking a lock. And then it sneaks inside. Those shapes sticking out on the outside of a virus are also what your immune system is feeling for, to figure out if this is a foreign invader, if it should attack or not. The problem is, the first time your body sees a virus, your immune system responds so slowly that the virus has time to make gazillions of copies of itself. And you can still get very, very sick. That's what's great about a vaccine. It trains your immune system what to look for, so when the real virus shows up, your body can respond super fast and destroy the virus before it has a chance to hijack your cells.
We meet again for the first time. Okay, so hopefully you have something that looks like this. M is the membrane protein. E is the envelope protein. That's kind of that outer coating there. And the spike protein is that sneaky protein that picks the lock of our cells and sneaks inside our cells and makes us sick. Now, it is important to know that there is RNA inside of the coronavirus, and we are about to learn why we care about this RNA. Now, there's a few different types of vaccines. In the past, we had a different way of doing vaccines. They were usually just weakened versions of the bacteria or virus that we were trying to fight. This clip is about to give you some examples of some of those old vaccines that you might have heard of before.
So what's actually in a vaccine? Well, sometimes a vaccine has a weakened or dead virus. That's how polio and measles and mumps and some other vaccines work. But these days,
All right, did you get that? Polio, measles, mumps, any of those ones could be examples that you could write down there. But brand new technology advancement. There has been some really cool advances, and he's about to tell you, actually, this is a different clip from CNBC recently that was explaining what some of these new vaccines are doing. So the two vaccines that are currently approved in the US are Moderna and Pfizer. And you may have heard that these need to be kept extremely cold. That's because of some complicated science here, but basically the mRNA that's in these vaccines will begin to break down at a certain temperature. So Pfizer needs to be kept especially cold. That was the very first one that came out. It needs to be kept to negative 70 degrees Celsius. That's way colder than in your freezers. The Moderna vaccine is still very, very cold. Remember, 0 degrees Celsius is freezing. Moderna needs to be kept negative 20 degrees Celsius, so it is way below freezing, but not quite as cold, so it's a little bit easier to get out into the world. There will be more vaccines on the horizon that can be possibly kept just in a regular old refrigerator.
The vaccine does the work. This week, the first evidence, the one from Pfizer and its partner BioNTech, is working. It's one of 3 different approaches scientists are taking in the U.S. Dr. Paul Offit says they all have the same goal: show the immune system part of the coronavirus, so before you get sick, your body can make the protective antibodies.
We know the protein of the virus that we're interested in. It's that spike protein, the protein that sits on the surface of the virus that allows the virus to attach to cells. If you can prevent the virus from attaching to cells, then you can prevent the virus from infecting cells, from infecting you.
Vaccines from Moderna, Pfizer, and others do this by delivering a piece of genetic material called messenger RNA. It tells our cells to make that spike protein, to which we then develop antibodies.
I'm going to play that last part one more time because that
The vaccine.
is a really important part. I'm going to put that on some slower speeds for us. So it goes into what the mRNA does exactly here. Okay, let's watch again.
Vaccines from Moderna, Pfizer, and others do this by delivering a piece of genetic material called messenger RNA. It tells our cells to make that spike protein, to which we then develop antibodies.
There you have it.
The vaccine.
So, as of right now, your notes should be beginning to look something like this. If I have pieces where it says watch, you need to make sure that you fill those blanks in. There should be at least 3 different colors going on your notes. Once you have it looking spectacular, take a picture and add it to your COVID notebook.